This lesson we are talking about the domain and range of continuous graphs. So this was the warm-up that we did in class, and I just want to go and I introduced the discrete graph and continuous graph vocab that I had you guys cut off of the previous notes. So we introduced that with the warm-up. So I just want to review again the warm-up. So the domain is the set containing -5, -1, and 3. We don't repeat the -1 for the x's, and we know the domains are the x's and the range are the y's. So the range is the set containing, that's what these curly brackets mean, 3, 0, -4, and 2. And to create the mapping, we know the first bubble, I don't know what the official word is, frankly, is all your x, and we don't repeat them. So you put your -5, -1, 3, and then here we have our range, which are 3, 0, -4, and 2, excuse me. And then you use arrows from the domain to the range. So in other words, from your x's, excuse me, to the y's in the range. So we know -5 is paired with 3, -1 is paired with 0, 3 is paired with -4, and then -1 is paired with 2 again, so it has 2 arrows. And that double arrow shows it repeats. And I know I asked in class, reviewing the previous notes also, is this a function? And I know many of you said no, because the fact that it had -1, either you can see that it repeats, or that it has 2 arrows showing that it repeats, means that it's not a function. Okay. Now, the only time, so you don't ever have to write a repeated x or a repeated y unless it's in a table. Okay. Then the table, you're basically copying all the points. But in the set notation for domain and range, using the curly brackets, and the mapping, you do not repeat things that are written twice. And then somebody asked today, well, is it okay if the range repeats? Can it still be a function? Yeah, we don't care about the y's repeating. All right. Now, like I said, when I introduced discrete graphs, I said that when I see the word discrete, because I know what the graphs look like, I always think of disconnected. So for example, I'm just going to draw a picture. Like in the previous notes, you had like a graph with some points, and you had to list out these points like this was, and then name the domain and range and the mapping and the table. So that was in the previous notes. And the fact is, they're disconnected. Nothing is connected. Now, the opposite, continuous, sounds like it's smooth and connected, right? Well, that's exactly what we're talking about when it comes to graphs. So any of the graphs that are smooth and connected, like these two, 4 and 5, that I went over or introduced the new part, which is this video, these smooth graphs, like in number 4, it's like this, we call it a parabola, it's a U-shaped graph. And then number 5 is an ellipse, which is the math term for ovals. You notice there's no gaps, everything's connected, and there's no holes. Like here, they're just all disconnected, okay? So the point is, and this is the point I made in class as with this warm-up, introducing this lesson that you're watching today, is I said, is it humanly possible to write down all the points that are on these smooth graphs like you did for this one where they're disconnected? So here there's 5 points, so it would be fairly easy to write the x, comma, y for 5 points, right? And then name your domain and range like this. Well here, no, you can't, because the fact that these arrows go on forever, it's just not humanly possible to find all the points. There's an infinite number of points. Same thing with the oval. Even though there's not arrows, you have to look at it as, sure, we could find the points where it crosses the grid perfectly, but these points, you have to understand, there's an infinite number of points because numbers get infinitely small as well. So there's still an infinite number of points. It's not humanly possible to write down all the points so you could individually list the domain and range. It's just, it's not possible. So we have to have a different method to find the domain and range of a continuous graph. And I'm going to say, so for example, I don't know if I should have put this, example graphs. So the ones that we used in class, we have this parabola, and then we also had the oval, okay? Those are examples of smooth and connected continuous graphs. So what do we have to do? Well, we have to do the scanning with our pencil, okay? So because the domain are the x's, and x's only go left and right, we have to take our pencil and scan from left and right. And if you notice, when we scan from the left, first thing we hit on the graph or this curve is the arrow. Well, if this arrow continues on it, it's going to continue to get wider and wider and wider, and eventually these x's, it's going to cover all the x's to negative infinity. So the domain is going to be from negative infinity, and with interval notation, you use the parentheses like we've been doing. So that's on the left side. But x's always go to the right too, and if you notice, my pencil, the first thing it hits is this arrow, okay? That also says that as it widens, the x's are gonna approach positive infinity. Well, anything that goes from negative infinity to positive infinity is basically what we call all real numbers. That's this capital double bar R, which means all real numbers. So from negative infinity to positive infinity is all real numbers, okay? I'll do the range in a second, which is the y's, okay? That goes up and down, but I want you to see the difference on the domain on number 5. We still go, or the similarities and the differences. So the similarity is you still scan from left and right. The difference is when I scan from the left, the first thing I hit is this edge, in fact, this point. And if you see this point, since this is the origin, it's -2, -1. Well, with domain, we only care about the x. Well, the x coordinate for that point is -2, so we start at -2. And anything on a solid line is a solid point, which we learned is a square bracket, okay? Then from the right, we scan, and same thing, we hit this edge right here on the oval, which is the point, so if this is 0, 0, it's the point 4, -1. But for domain, we only care about the x, which is 4. And again, it's a solid line, which is a solid point. So we use the square brackets that we learned, okay? So again, for domain, the x's, we go left and right. Now the range, we know for the y's go up and down. And we always, just like we start on the left for the domain, okay, because we always want to do it on increasing order and the negatives are less than the positives, we do the same thing with the range where we start at the bottom, then we do the top, because you always want to go in increasing order. So if you notice here, when we go from the bottom, I hit this point first when I use my pencil to scan. Well, the y on this point, well, since this point is 1, -4, the y is -4. We only care about the y for the range, so it starts at -4, and since it was the solid line, it's a solid point, comma, then we do on the top, well, I hit both arrows. Well, that means the y's are going to continue to go to positive infinity. They're going to keep getting bigger and bigger, so then you just put your positive infinity with the parentheses, okay? And again, on the range for number 5, we do the same thing. The similarity is that you start from the bottom. The difference, well, I guess we hit a point here too, but we hit this edge, or this point is the lowest point, and those coordinates are 1, -3, and for range we only care about the y, so we do -3. Then from the top, the difference is we don't hit the arrows, but we hit this edge. We just do the same thing where we find the point, which is 1, 1, but we only care about the y, which is 1, and it's a solid point because it's a solid line, so we use the square brackets. So basically the range, all the points, if we could humanly, if it was humanly possible to list all these points, the y's would be between -3 and +1. There would be no other possible y's. It would only be between these values. kind of like the domain. If we listed all the possible points, the x's would only be, the lowest would be -2, and then everything to +4 and nothing else, okay? So let's go on. So on this sheet it says for domain, scan your pencil, and again remember domain are the x's, scan your pencil from left to right along the x-axis, because that's the x's. Now the range are the y's, so we know y's go from up and down, but I just say, so from the bottom to the top, because we always want to go in increasing order, and we know y's are negative at the bottom and they're positive at the top, and negatives are always less than the positives, and we do it along the y-axis. Okay, and just remember this capital double bar R means all real numbers, and that is anytime you get -infinity to +infinity. So on number 1, if you notice for domain, again we go from left and right, first thing you notice is I hit that arrow. So that means right away it's going to go to -infinity. In other words, it's going to keep going this direction, so all the x's are going to keep getting more and more negative on all those points. Oops, I don't know why I put that parentheses. Should be a comma, because I still have to go on the right side. Well, on the right side I hit this arrow, which also means as this goes on forever and ever, the x's are going to keep getting bigger and bigger forever, so it's +infinity. And this means all real numbers, okay? Now the range, I know I go from the bottom. Well, the first thing I do is I hit this point. All we care about is the y coordinate, which is -2, so it starts at -2. And then on the top, I'm gonna hit both of these arrows. Like if they were the same distance, I'd hit both. It doesn't matter as long as you hit one. That means the y's are gonna continue to get bigger and bigger to +infinity. Okay, now, this is where we introduce our inequalities. When it's all real numbers, we don't write inequalities, we put that it's all real numbers using this capital double bar R. That's the symbol for all real numbers, okay? But since range are the y's, if we're gonna write this as an inequality, because you're gonna need to write it as interval notation and the inequality, so the capital double bar R is considered as part of your written answer, and we do the inequality when it's not all real numbers. So we know we start with y, because we want the variable on the left side, and that's your range. But notice we say y is kind of like we equate it to the extreme, which is one of the infinities. Okay, well, so if the majority of the y's are +infinity, is that bigger or smaller than -2? Well, it's bigger, so we say it's greater than, and since we use a solid bracket, or the solid point bracket, we do the or equal to -2. Okay. Now number 2, so the domain, we scan from the left. First point we hit is here, and domain we only care about the x, which is -3. So we start at -3, comma. From the right, I hit this point, which is +3, because we only care about the x on that point. And then how I write this as an inequality, because it's not all real numbers, remember those less than sandwiches? We just write it, all the x's have to be between this. It's kind of like these barriers, it has to be between, so we just write -3 is less than or equal to x is less than or equal to 3. Now the range, we go from the bottom, we hit -3, and then on the top, oops, I should write that, -3, and then on the top we hit this point, which the y is +3. Which should make sense, because a circle, if it's centered at 0, 0, it should make sense that the coordinates should have the same distance from 0. And we know 3 and -3 have the same distance from 0. And with range, it's y's, and so it's just the same kind of less than sandwich, except we're using y's. So we have -3 is less than or equal to y is less than or equal to 3. Now a little tip on number 3. I just noticed, and again my experience I'm sharing with you, some tips. when I go from the left, I hit the arrow, from the right, I hit the arrow, from the bottom, I hit the arrow, and the top, I hit the arrow. Well, guess what? If I hit the arrow in two directions, like from left to right, then the domain is automatically from negative infinity to positive infinity, which means all real numbers as your written answer. And if it's from the bottom, I hit the arrow, and the top, then the range is also negative infinity to positive infinity, which means all real numbers. So I quickly can tell if I'm going to have all real numbers for both domain and range if I can quickly see when I'm scanning that I'm going to hit arrows in all four directions. That just might be a time saver, okay? Now if you look at number 4, so we just do the same thing. We always start with our scanning from left to right for the domain. So on the left we hit the arrow. Even though it's going down, that doesn't matter. The point is it's going to keep getting wider and wider, which means is the x's eventually are going to hit negative infinity. And then if we go to the right, we hit the arrow, same thing. It doesn't matter that it's going down. The point is it's getting wider and wider, so eventually the x's are going to go to positive infinity. And again, we've learned that that means all real numbers. So the range, we're going to go from the bottom to the top, and if you notice the bottom, I hit the arrows. Well, if the arrows are pointing down, that means the y is going to continue to decrease to negative infinity forever. And on the top, I hit this maximum point, and we only care about the y, which is 4. And we're going to use the square bracket because it's a solid point. Now, we know it's y, and we have to write our inequality. And the bulk of the negative infinity represents the bulk of the y. So I always ask, and we call this the extreme. Either the positive or negative infinity. If there's only one of them, we call it the extreme. You'll hear more about that in Algebra 2 for sure with extreme behavior. So is the negative infinity bigger or smaller than 4? Well, we know negatives are smaller than positives, so y has to be less than or equal to 4. And again, we use the or equal to because of the solid point on the 4. Now, number 5, I scan from the left, I hit -1. I scan from the right, I hit, what is it, 1, 2, 3, 4, 5. So positive 5, I know that's a less than sandwich, so it's -1 less than or equal to x, less than or equal to 5. From the bottom, I hit -3 on the y, and on the top I hit positive 3 on the y. I do my less than sandwich because there's no infinities whatsoever. So I have -3 is less than or equal to x is less than or equal to 3. Now number 6, this swoopy part doesn't matter, it's the end. So if I quickly determine I'm going to hit an arrow, 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 automatically I'm not going to waste any time. I just know it's positive infinity to negative infinity, which means all real numbers for both domain and range. Okay. Now, number 7 seems a little strange. The whole point of this graph, and maybe make this a little bit easier to see by having it point, is that it's going to oscillate between these two max and min points for the y's, okay? So it's trying to let you know that it's just going to keep repeating and it's not going to go any further than +2 for the max on the y and -3 on the y. So I want you to see that if you hit the arrow from the left and the right, we automatically know the domain is from negative infinity to positive infinity, which means all real numbers. But the bottom, I need you to understand, you're never going to hit the arrow because you're going to hit basically all these points at the same time. And we only care about the y. Well, the y is -3, so we start at -3 and they're all solid points. And then on the top, we're never going to hit the arrow because it's going to continue to go back and forth, but we do hit all of these top points at the same time, and we only care about the y, which is 2. And remember I said if there's no infinities, it's just a less than sandwich, so we have -3 is less than or equal to x is less than or equal to 2, and we're done. Okay, same thing for number 8. Go from the left, I hit this point, we only care about the x coordinate, which is -1. And then on the right, I hit both arrows, which means the x is going to keep going to positive infinity. Since there's one extreme with the positive infinity and the domain are x's, I'm going to write it as x, and then I ask myself, is the infinity bigger, is positive infinity bigger or smaller than the endpoint, which is -1? Well, we know positive infinity, or all positives, are greater than -1, so x has to be greater than or equal to -1, and we use the or equal to because of the solid points or the bracket. Now the range, from the bottom I hit the arrow and the top I hit the arrow, so I can quickly see it's going to be from -infinity to positive infinity, which is all real numbers. Now, vertical and horizontal lines. Once you understand these, they're really, really simple. I just need you to understand that the arrows for a vertical line are strictly pointing up and down. So like when I go from left to right, I actually you can't hit the arrow sideways because it's not going left or right at all. So if you look at all these points, well, they all have the same exact x value. In fact, all the x's are +2. And remember, domain, we only care about 2. So actually, 2 is the only number. And we can't even write it as interval notation because there's no interval. It's one single answer. So basically, this is your written answer and your interval answer, okay? But the range, if I go from the bottom to top, I hit both arrows, so it's from -infinity to positive infinity, which is all real numbers for the y's. It's kind of like the opposite for a horizontal line. If I go left and right, I hit both arrows because we know horizontal lines go left and right. So the domain is from -infinity to positive infinity, or all real numbers. But if I go up and down, you can't hit arrows sideways because arrows or horizontal lines don't go up and down at all. So if you're checking from the bottom to top because the y's go up and down, basically you're just looking to see, oops, boy, I missed that mark. You're looking to see what the y values are. All these points have the same exact y value, which you can see is -4. So the y is always going to be -4, and that's it. And again, like I said, when there's one number, when it's the same all the time, as you can see, all the y's are going to be the same, we can't write it as interval notation. So basically, the written is both the interval and the written. Anyways, so bring questions. We're going to practice this in class. Domain and range is a huge skill that you're going to see in Algebra 2 and pre-calc and beyond a lot. Like you think we're going to do a lot this year, Algebra 2 is way more. So bring questions.